Welcome back to the Atari ST Nostalgia GFA Basic Tour. In Series 2 we ended up moving some graphics around on screen and then looked at the compiler. And at the end of Series 2 I was not sure if or when I would do a Series 3. But I just couldn't resist, so here I am. Series 3 is about to start. And this series will mainly be focused on exploring the graphics capabilities of GFA Basic a bit further. Because in Series 2 we moved graphics around, but never like over a background, so I was actually cheating a bit, and there's more advanced stuff you can do. So let's go on an adventure to see how we move graphics over a background. And I have already been making some code, and basically what this code does is, I do some preparations. In this case the preparations are just two arrays I create to store some coordinates. I'm going to do a pre-drawing like a canvas and then some objects to animate over the screens and getting them into memory. And then I'm going to use my knowledge from part 23 about the orbit routines with the synq and cosq commands to actually calculate coordinates and input them in the array. And then I'm going to read the different positions of the array to put one object after the other. And I'm going to put the first objects the last, so it's always on top. And this is basically the same routine I used in part 24 for the line bouncing routine. It should be a movement of many objects on screen over a nice background. So let's see how it works out if I very naively just run the program from here. As you can see, the background was being drawn, and then I draw a bunch of 16 by 16 pixel sprites, which in monochrome look a little bit small, but I want to explore different ways to move sprites, and one of the commands is actually limited to 16 by 16 pixels. So to have everything equal, I will just use 16 by 16 pixel sprites, with some letters to enable me to spell out ST Nostalgia. And then to the right there is one sprite which is a white diamond with a black background, so reversed from the other ones. And that one I'm going to use later in the video for a process called masking, but that'll be further up in the video. And of course that's one logo which is actually 96 by 32 pixels to also move around on screen. So let's move them around, and as you can see, this is not working. And the reason it's not working is of course pretty obvious, because I am putting all these sprites on screen, and I made an end transition also, which is just a bunch of P boxes, and I'm not going to explain that part of the code. But you can see, I am putting all these sprites, but I'm not cleaning up anything. And in part 27, I also just put the sprite there, but I actually was grabbing some white space around it. So whenever I put the new one, it actually automatically took care of the cleanup, because I was putting it in mode 3, like the replace mode, and now I'm using mode 7. And the most easy way would be to just put the background, use sput canvas string. So in every loop, before I draw the new sprites, just put the background again, so everything gets cleaned up. So let's see how that works. And as you can see, the pre-drawing is still the same. And now the good news is, yes, the cleanup is working, but the bad news is, as you can see, the animation now got really flickery, and that's because right in my visible screen, every time I'm putting the background there, and then I'm putting the sprites on top, so it's alternating each other, which creates this effect, and we really have to fix this. So we have two major problems to fix, and we will do it in this video. The second one being this flickering, but actually the very first one I want to fix is actually all this pre-drawing of my sprites is also visible on screen, and I don't want that. So what I want to do is actually create all the graphics without them being visible for screen. And in that respect, I did some visualizations even to better explain it. We have to remember that all commands, including the graphics commands, basically write a bunch of bytes into memory. And any bytes in memory that are then read by the video chip, by the shifter, is interpreted, converted to an analog signal, and then put on the screen. And by default, as you can see, my graphics commands are writing to an address that's held by a command called xbios3, which I can read into a variable logical screen if I want to. And the shifter at the same time is reading from an address held by xbios2. And by default, they are exactly the same. But wouldn't it be great if I could just tell actually my graphics commands to not write to this default xbios3 command, but write somewhere else. So I will put some address somewhere and reserve some memory and say, oh, this is my buffer screen. I want all my commands to be executed there. And the shifter should not read from there. So my screen will not change, but in the meantime I can put graphics. And the good news is, yes, we can. And I want to show you, let me go back into my play screen, not play screen, but into my editor. And yeah, I've created the code. I'm not going to type in everything because it will just take too much time. And as you can see, I've added a bit to the code. So the preparations are the same, but then I'm going to go into a buffer screen and then do the pre-draw procedures, go back to my default screen and then do the animation. So what do these commands do? I will go to the preparations first. And as you can see, the arrays are still there, but now I'm creating an extra array called pre-draw buffer. And this array consists of 32,255 bytes, so it can hold the 32,000 bytes that one screen is needing. And then I'm going to read some variables. So these XBIOS3 and XBIOS2 that you saw in the visualization I just showed, I'm going to read the numbers that they are holding and write them into variables, in this case logical screen and physical screen. And I'm going to read another variable called buffer screen, which basically is the address. So I'm using the var_ptr command, and this is the abbreviation. So I'm going to read the address of the first element into this pre-draw buffer, then add 255 to it, and then AND that value with this hexadecimal value. And this I have to do because the Atari ST shifter and the graphics commands, if you want to use something as a screen, the address has to be a multiple of 256. That's just something the default ST has. So we need to apply this formula to make sure it is divisible by 256. How this ending exactly works in detail, I don't know, and also I don't care because it's just in the manual. I can use it and it works, and that's all we should worry about. And just to show you that actually the numbers for XBIOS 2 and 3 are the same, I'm going to clear the screen and I'm going to say print XBIOS. First I'm going to do the one for the physical screen. And as you can see, the address value is 1015.808. So you can also see that this memory is actually right at the top of the memory of my 1 megabyte machine. And if I do the same for XBIOS 3, you can see the number is exactly the same. So this is the default configuration. Wherever I write, the shifter will also read and display it immediately. And I can also look at another one, XBIOS 4. That one is responsible for holding the screen resolution, which in this case is 2 because I'm in high resolution. And medium resolution in color would be 1, and the low resolution would be a value of 0. So I did these preparations, created the array, so I created some space in memory where I want to hold the screen data. And then I'm going to go to buffer screen using another command, XBIOS5. And this command, I can tell the system where the graphics command should write, so what the graphics command should treat as their logical screen, like the XBIOS 3, and then set the new value if I want to for the display screen, so where the shifter wants to look. So I can make these values different, therefore be able to write something to screen with graphics command without the shifter showing it. And it also asks for a resolution to set, where -1 means no change for any value, and for resolution 2 means high res, 1 is medium, 0 is low, as told. And when you set the resolution to any value, the screen gets cleared. So my preference is for the resolution, always use -1, because if you want to clear the screen, then just use a command to do that, but don't do it from here. And in this case, I'm going to tell my system, look, all my graphics commands, they should actually write to this address, this buffer screen address, which is the multiple of 256 at the start of the array. And the shifter should do what it has been doing, so keep reading from the default location. And that means that anything I do in my pre-draw procedure now actually gets written into memory, but the shifter won't pick it up. And of course, after the reader, I'm going back to my default screen, which basically I will say, like, the shifter, whatever it was, go back to your variable physical screen, because in my program also I never changed the value of this variable. So go back to your default location that I read, and also all graphics commands should write to the same location. And I'm using the same variable because basically it reads the variables, applies the numbers, and after that it doesn't do anything with the variable. So it doesn't matter if you use the same name here. As long as you make sure it's the default location and the numbers are the same, then it will be back to its default location configuration. So let's see, the pre-drawing should now be completely invisible to us. And sorry, that was a lot of explanation, but I think it's important to understand. And as you can see, the animation is still really flickery because I did not fix that part, but the pre-drawing was completely invisible to us. So that part we have fixed. But now this flickering we still have to fix. And we need to do something for that. And actually I'm going to load some other code to sort of explain it a little bit better. Because basically what I'm doing in in this animation is I'm doing the pre-drawing, and then actually every time I'm putting the canvas and then do a bunch of drawing commands. And I'm going to explain it by putting the canvas and just drawing random P circles. So this, what we see is a sort of very exaggerated form of what we saw with the sprites. It's the canvas is being put there quite quickly, but actually you can see the circle gets drawn. And I want to show these circles, but I don't want the drawing to be shown. So what I would like to do is actually do a pre-drawing, like pre-draw my canvas, put my circle there, and then show it on screen, and then pre-draw it again, put the circle there, and then put it on screen. And that procedure is also possible because we already know, we already gained some knowledge about how to pre-draw. So it works in multiple times. So basically, this was the default configuration, and we're already pre-writing to a buffer screen while the shifter wasn't reading anything. But what if I could just, after doing this pre-draw, tell the shifter to read from this buffer screen location where I put all the graphics, and at the same time, like so, I will actually say, okay, now I'm going to write my commands at the position where the shifter was reading, but not anymore. Because as you can see, after we did this and we swapped the addresses, so the screen of write to and the screen it's reading from, I swapped the two. And now the shifter is actually showing this P box I just drew, and in the meantime, I'm actually drawing a P circle in my screen that the shifter is no longer reading from. And then I can swap again, and the shifter shows the circle, and I can do the next one on my buffer screen. And that procedure is called screen swapping or double buffering, and that's what I want to do. And the way to go about it is actually, we use all our existing knowledge already, and I only have to add an extra procedure. And actually also make sure I started my buffer screen. And the procedure is called swap, and basically what it does, it uses the swap command to swap the values of the variables buffer screen and logical screen. So the number that was in logical screen will be in buffer screen, and the number that was in buffer screen will be in logical screen. And it doesn't move the bytes or anything, it just changes the pointers. So it's really fast, it's almost instant. And also this command, I will keep telling, like, go to buffer screen for my writing and read from the variable number that belongs to logical screen. And because I keep swapping them, you can see the swapping effect that I just visualized. And now let's see how it works out for the circles. And as you can see, the drawing is still done off screen. But as you can see, now the circle, instead of watching it being drawn, it's on screen almost instant, because all drawing commands that take time, they are all done off screen. So the displaying of everything is done exactly at the same moment and completely instant. And in this case, what you can also see is that there's still a pause between every displaying of the circle. And that's not because I put some pause in the code. It's because the drawing of everything off screen still takes the same amount of time. I mean, the graphics commands are doing exactly the same as when I'm writing directly to screen. So they take exactly as long. They interpret my data, convert it, and put data in memory. And it doesn't care where the memory is. The command will take just as long for every single instance. So we have to take that in mind, that we can't do too much off screen when the animation still get very slow. But at least the flickering is gone. Everything I show is just shown instantly. And that's the double buffering screen swapping that I want to do. And I have actually incorporated in my code like so. So as you can see, everything in this code is exactly the same, exactly like I'm putting a canvas there, instanting coordinates, instanting all the objects. But I'm doing everything in my buffer screen, so off screen you don't see it. And after that I'm doing the swap. And it will show like the whole screen with all the sprite instantly. And exactly like I did with the circle. And as you can see, yeah, this is starting to get something, because now all the flicker is completely gone. And that's actually really cool. And we are almost done, except for one problem, which I can show you by pausing the emulator. Because actually, as you can see, I am putting the small sprites in put mode 7, which means transparent. Which is nice, because the white space around the diamond is not being put in screen, which is really cool. But also the white inside the sprite, because it's the transparent color, actually the background shines through, which makes the letters really difficult to read if the background is anything else but white. And I don't want that. I want a solution for that problem too. So we've come quite far already, but there's one last thing we have to do, and that is what the mask sprite I showed you in the beginning was for. I'm going to load my new code, because remember, I created this small sprite, this white diamond with black background, so it was a reverse from the other ones. And what I'm going to do is do a procedure called sprite masking, and I'm going to add that to the thing I'm going to do off screen. And the way masking works is I have to have a sprite that is reversed, and I'm going to put that mask. So here's the new bit of code. So for every position down here from 0 to 22 in steps of 2, which I'm going to do here, I'm actually going to put at these coordinates, I'm going to put a sprite called mask, which is this reverse diamond, and I'm going to use put mode 1. And put mode 1 means it will only be a black pixel if the source pixel was black and my destination pixel was black. So the black background around my white diamond, in that piece, if there was a black pixel in the background, it will remain black. And if there was a white pixel in the background, it will remain white. So basically the black background over this background in put mode 1 will leave the background intact, except for the white circle in the middle, because yeah, if it was white on white, or it doesn't matter, it's not black on black, so it will become white, and I will sort of create some white holes in the background, and then I will put my my sprites on top of it, which will still be transparent, but the part of the background shining through the sprite is actually solid white, so it looks still like white letters. And I'm doing it directly on screen without swapping and adding some key press, so we can see the process in working. But explaining by words is kind of difficult. And as you can see, yeah, it puts the background and then it does a 3-step process, and I will just continue a little bit so it's visible a bit better. So here is the background that it put. Then it's actually putting all the mask sprites, and as you can see, the white diamond becomes white, and the backsplace that was around it remains the same in the whole, the background stays the same. And then I'm going to put the sprites on top of it. And as you can see now, the letters are actually white instead of this gray pattern going through. And yeah, it's also a 3-step process now. So I'm going to yeah, make sure I have a clean sheet. So I'm putting the canvas in this case. Start off with a clean sheet, put the masks, and then put the sprites. Start with the clean sheet, put the masks, put the sprites. Start with the clean sheet, put the mask, put the sprite, and so on and so on. Of course, if I have to press a key all the time, it's not very fast. But actually, if I remove this pauses for waiting for a key press, we can see the end result happening. And in this case, I should also, and then add the swap procedure, and then run the program. And now we have achieved exactly what I wanted to achieve. So my drawing is done completely off screen. My sprites are getting cleaned up so they don't leave any trails, but also the flickering is gone by using a swap procedure, and I made sure the letters inside the sprite always are a nice solid white so they can be read properly regardless of the background by using this procedure called sprite masking. Now what we can also see that compared to the beginning, the movement actually has gotten quite slow, because yeah, now it has to do so much, and I am not doing everything in a very efficient way, because this video was not about performance, it was about learning how to move sprites over a background by yeah, cleaning it up and using sprite masking and using the swap procedure to make it flicker free. And those 3 things we learned, but we still need to do some work yeah, to increase the performance a bit, but that's something we will actually do in a future video. Yeah. In summary, what we'll do, yeah, in future videos we look at ways to improve the graphics around and not use the get put command, and see if we can make things a little faster. But in this video we learned how to do screen buffering, drawing off screen, do screen swapping for flicker free animations, which is really cool, and we learned about sprite masking to actually make sure our sprites are nicely visible even when they're transparent on screen. And we will build on this same procedure with different commands in the future. For now, I would like to thank you for watching this video, and I hope to see you next time.